Hi you guys, so this is number 1 from our homework sheet, graphs of f of x and f prime of x. And this is a graph that's given to you. This is actually, the graph of f prime of x, and it's your job to find what the original function's graph would look like. So the first thing I do is section off the graph at all of its important parts. As you can see, I've sectioned off the graph at each one of its zeros and at each one of its critical points, which is a max and a min. And from there, I go ahead and extend it because we're going to look at every single section and determine what's happening in the first derivative graph, which will tell me what's going to happen in my original graph. I'm even going to be able to tell what's happening, not so much necessarily in the second derivative graph, but what the first derivative graph can tell me about its concavity at that point. So first things first, let's go across, only examining what's happening in the first derivative graph because that's what we're looking at. So I'm first looking from the x values of, or this first section right here, just to let you know where I'm starting at. Looking at that section, I can tell that this whole section is negative because it's on the bottom side of the x-axis. So I'm going to put a negative sign right there. Next section, or the second section, I see that this graph is above the x-axis, so it's positive. Third section, it's still above the x-axis, so that part of the graph is still positive. Let's see, 1, 2, 3. The fourth section, it dipped below the x-axis in this section right here, and so it's back to being negative. And this fifth section, even though it's starting to change direction, it is still below the x-axis, so it's negative. And from this final section going all the way up here, it is above the x-axis, so I am going to put that it's positive. Now, it might be helpful for me to look at my my chart on the characteristics of f prime, and f double prime. But from what I can remember, and hopefully we are getting this into our memory, wherever my first derivative graph is negative, then my original graph must be decreasing. If my slope is negative, I have negative slope, I must be decreasing, right? So now I'm going to go across and put in the characteristics for the first, for my original graph. So again, my second derivative, my first derivative is decreasing. It's negative, so my first graph should be decreasing at that point. And where my second derivative is positive, my graph should be increasing. So it'll be increasing, decreasing, decreasing, and increasing. And just by using those arrows, I'm getting an idea of what pattern my graph is going to be following. Last but not least, let's talk about concavity. So whenever my first derivative graph is increasing, my original graph is going to be concave up. And wherever my first derivative graph is decreasing, my original graph is going to be, if the first derivative is decreasing, my original graph is going to be concave down. What do I mean by that? Well, look here. In this first section, we're increasing from there to there, right? So that means since my first derivative graph is increasing, my original graph is going to be concave up. And if you notice, it continues to increase, right? It's still increasing. So it is still going to be concave up like a cup. But now I come to a point in my graph where I am decreasing. So I am now decreasing. So my original function should be concave down like a frown. Still decreasing. I am still concave down like a frown. And now I am back to increasing. So this would be concave up. And continuing on forever and ever and ever. I will be, since I'm increasing at that point, the graph would be concave up like a cup. All right, so now using what I have for each of these sections, I should know how to draw this graph. So let's look at just the first section. It's saying that I should be decreasing, but concave up. So I'm decreasing, but concave up. Next section, I should be increasing and still concave up. So I am increasing and concave up. Be nice if I can connect these. Yes. Next, I should be increasing but concave down. Increasing and concave down. Increasing or decreasing concave down. Decreasing concave up, and then increasing concave up. Let's see if we can get it to connect. And that is a graph of the original function. Now, it can be, and these are sometimes called a parent, or there's a parent of functions, because we don't know exactly where the points of this graph are. We only know the behavior of the graph. It would not have hurt then if you would have drawn, I'm sorry, it's not going to be super duper perfect, but if you would have drawn your graph there or even here, I'm just trying to quickly get the concavities. It would not be incorrect because we do not know exactly where this graph is. The graph that we're given is only the graph of the behavior of the slopes. It does not give us the exact value of the original function. All it's telling me is what its behavior is. Where is it increasing? Where is it decreasing? And where is concavity changing? So yes, there could be multiple correct answers as far as your graph, and that's the answer.